Okay, so now calculate the limit as x approaches 1 of f of x. And I have to tell you what f of x is. Okay, so now this is a little bit different because now we have a piecewise defined function. I'm going to give you a timer. I want you to think about how you might compute this limit. I want you to be very careful. In your scratch work, try to be very precise about what you're doing and why you're doing that step. So let's say 2.5 minutes. And then we'll go over it. And if you're not sure what to do, try to think about what you might do and try to write down as much as you can about what you think is happening here. You saw this on the YouTube channel yesterday? Oof. But now you forgot it. That's good. That actually is a good way to study, right? Sometimes reading a solution or watching a solution and then coming back to it the next day, right? Because you probably forgot it. So now you can see if you really do know it. And I asks, will there be 2 solutions? I don't know, will there? I'll ask that to the class once we're done. I guess I should get a link to the YouTube channel. Gotta plug it. There we go. Yeah, like and subscribe, please. And that's then I link the actual playlist that we're looking at. This professor, it's just Zoom University. I'm just giving you YouTube videos to watch. Just this professor. But I made the videos, so it's okay. All right. So how do we do this? So first of all, someone asked a good question. So I asked, will there be 2 solutions? What do you think? So Justin, you are shaking your head. So can you explain that? You said there will not be 2 solutions. Jacqueline is saying there's no solution. Thomas is saying a left and a right solution. Camille is saying the limit doesn't exist. Justin agrees with that. Caleb is saying right. I don't know if you're saying right isn't correct or just like the right limit. I don't know. Agree does not exist. Okay. So it looks like a few people have kind of figured out, yes, the answer is the limit doesn't exist. And it looks like, so yes. Left and right solutions, but not the main solution, right? The two-sided limit, left and right are different, so it does not exist. Okay, good. I think Thomas was the first one to say that. Let's give him some credit, Thomas. So yeah, so basically how this works is for left and right, for a piecewise defined function, the idea is you generally want to look at left and right limits, particularly, notice that x is approaching 1 in this case. Oh, it always freezes afterwards. X is approaching 1 in this case, and notice x equals 1 is also where the two parts of the function kind of switch, right? So we usually call that a transition point. It's not an exact term, but that's we'll call it in this class. And so if you're computing a limit at a transition point, that means you should be looking at the left limit and the right limit separately. Now, in this case, you get the limit doesn't exist. I don't think that really answers the original question. The original question was, so are there two solutions? So to be very clear, a limit is a number, right? A limit is unique. If a limit either does not exist or is some number. There's no such thing as the limit is both 1 and -1. There's no such thing as a limit having two values. Limits are unique. So there's never two solutions. It's either the limit doesn't exist or something else. Okay, so let's kind of write all that down. So note that x equals 1 is a transition point for f of x. Right, and again, what do I mean by that? I just mean that that's the value of x where the two pieces switch over, right, where they transition. So we are going to examine this using one-sided limits. And again, the reason we're doing that is because if the function is different on the left of 1 and to the right of 1, that means if I were to do an overall limit, it's very difficult, right? Because I can be considering values of x that are both less than 1 and greater than 1, and I have two different formulas for that. But if I restrict my attention to just the left side or just the right side, then I have one formula for each of those sides, right? So it's a little bit easier to do the one-sided limits in that case. So let's see, there's a question in the chat. So if there is a limit for a piecewise function, it never exists? No. What I was saying was a limit either doesn't exist or it equals some number. So to answer your original question, there's no such thing as something having two limits at the same value of x. Like there's never two solutions. Okay, so let's look at the left limit first. Okay, so let's look at limit as x approaches 1 from the left. And keep in mind what this means. Let's be very, very precise about what we're doing here. So this means two things. Can someone tell us what this means? The limit symbol, lim as x approaches 1 from the left. In general, what does that mean about x? And there are two distinct pieces. Okay, so Thomas says less than 1. Good. So x is definitely less than 1. And there's one other little piece. This might be a little bit more difficult to kind of figure out. Oh, close to 1. Good. Margaret, that's correct. Never equal to 1, but x less than 1 already takes care of that, right? Strict inequality. What I was really going for was close to 1 and less than 1. Okay, so in this case, if x is allowed to be only close to 1 and less than 1, we look at the definition of f, and we see that if x is close to 1 and just less than 1, that means f of x is equivalent to this square root expression, right? right? F of x is equal to that x square root if x is close to 1 and less than 1. And then how do I actually compute this limit? Well, now I just use direct substitution property, right? I can just plug in x equals 1 and I get 0. Okay, right? It wasn't supposed to be a difficult limit, but the idea was we have to understand how we're actually, why are we doing left limit and right limit? And now let's do the right limit. It's going to be a very similar argument. Okay. So first, let's copy this. So now that x is approaching 1 from the right side, what does this mean? Again, it means x is close to 1, but the only difference is what? Now x is greater than 1, right? I can't consider x values that are less than 1. And the only real difference here is that now I'm using a different formula for f, right? If x is approaching 1 from the right side, that means x is bigger than 1, and so x now has a different formula, right? I'm not going to use the square root formula. I'm going to use this rational function formula. What the hell was it? It was x squared minus x. Okay, now the only complication here is obviously I cannot plug in x equals 1, right? I get division by 0. So now we just have to do a little bit of algebra. So we can see that if I factor out the x here, the x minus 1 cancels out, right? And I'm allowed to do that again because if x is not equal to 1, the factors cancel out. I'm left with just x. And so I plug in 1 into that. If I plug in 1 into x, I just get 1, right? So again, I'm using direct substitution property there. Now, as a few people said in chat before, so you work at the left limit and the right limit. The left limit was 0. The right limit is 1. They don't equal each other. So therefore, the overall limit that we actually wanted to compute from the start doesn't exist. All right. So let me just write that out kind of explicitly just to remind you why we're concluding this. So since the left limit at 1 does not equal the right limit at 1, the overall limit does not exist. Questions about this? So in general, when you're faced with a piecewise function and you're trying to figure out the limit of that function at a transition point, you should actually switch to one-sided limits.